So for lesson 8, this is just a more complex equivalency. We should now have a better ability to work with exponents. In this lesson, we'll continue to explore expressions that are equivalent but look different. So equivalent means that they are the same values. So we're looking at x minus 2 times x plus 5, and we're seeing if it's equivalent to one of the expressions below. So see if it's equivalent to x squared minus 10 or x squared plus 3x minus 10. In order to do that right now, we're just going to plug in 3 in the first row and then 5 in the second row. So in the first row, instead of x every time, I'm going to write 3. So I'm going to go through and do that first, so I don't remember or don't forget what it's asking me to do. So 3 squared plus 3 times 3 minus 10. Now that we have that, we need to do order of operations. So 3 minus 2 is 1. 3 plus 5 is 8. 1 times 8 is 8. The next one, 3 squared is 9. 9 minus 10 is negative 1. And the last one, 3 squared is 9. Plus 3 times 3 is 9 minus 10. Well, 9 plus 9 is 18. 18 minus 10 is 8. So looking at those, do we have an equivalent expression? Well, I have an 8 here, and I have an 8 here. They have the same answer. So now we need to check and see if the same thing will happen if I plug in 5. So we're going to do the same thing as before. Every time there's an x, we're going to plug a 5 in instead of it. All right. Now we're going to do order of operations. 5 minus 2 is 3. 5 plus 5 is 10. 3 times 10 is 30. 5 squared is 25. Minus 10 is 15. 5 squared is 25. Plus 15 is 40. Minus 10 gives you 30. So again, looking at that, we do have 30 for both the same ones. So yes, those are equivalent expressions. The last exercise is pretty interesting. It would seem that if you were mindlessly manipulating the product of the two binomials, then you would likely think the two expressions were equivalent when they are not. Let's find out with the next exercise how to show or how to multiply the two binomials using a variety of properties. So the first thing that happened is it took x to the third power, this original x to the third, or sorry, not x to the third power, x plus 3, and that did not change on the other side of the equal sign. But it took x plus 3 twice. So what it did is it actually split up this x to the fifth and put it times x plus 3. Sorry, just the x, I'm struggling. And then it took this 5 and multiplied it just the x plus 3. So what it really did was the distributive property. Then the next one, it took your result from up above, and instead of x plus 3 times x, it became x times x plus 3 times x. And instead of 5 times x plus 3, it became x times 5 plus 3 plus 5. So again, it did the distributive property. It just distributed from and took away the parentheses. On the last one, it took all of the x's, so x times x plus x times 3 plus 5, because up above I have a 3 times x and a 5 times x, so it took the 3 plus 5 and said, okay, I can actually combine those and multiply them by x, and then the 3 times 5. So again, this was another distributive property. That was a lot of justification. The process of multiplying binomials is very important in algebra, so it's another skill we would like to get fluent with. Get some practice in the next exercise. Keep in mind that you are simply doing the distributive property twice. So in the first one, x plus 6 times x plus 3. So what we're really going to do is we're going to take this x plus 6 and write it out twice. The reason why we write it out twice is because there are two terms it will be multiplied by. The first term is multiplied by x, and it will be added to the term multiplied by 3. So now we're going to just distribute. So x times x is x squared. X times 6 is 6x. 3 times x is 3x. 3 times 6 is 18. And then we combine like terms. So x squared plus 9x plus 18 is the simplified answer. So go ahead and do the next 5 on your own. Pause whenever, play whenever if you feel like you got stuck. So I have x minus 4 times x plus x minus 4 times 6. So x times x is x squared. X times negative 4 is negative 4x plus 6 times x is 6x. 6 times negative 4 is negative 24. Combine like terms, and you get x squared plus 2x minus 24. Instead of writing it out every time, you can simply do what's called FOIL. So you do the first number times the first number, which is x squared. So F is for first. Then you do the outside numbers. So x times negative 3 is negative 3x. So outside. Then we do the inside numbers. So negative 3 times x is negative 3x. Inside. And our last one is our last numbers. So last. Negative 3 times negative 3 is positive 9. Again, you're going to combine like terms. Negative 3 and negative 3 makes negative 6. So x squared minus 6x plus 9. So you can do FOIL as well. That's just another strategy. If I do that, then 2x times 3x is 6x squared. 2x times 1 is 2x. 3 times 3x is 9x. And 3 times 1 is 3. Combine like terms, and it's x squared plus 11x plus, 6x squared plus 11x plus 3. 3x times 3x is 9x squared. 3x times 2 is 6x. Negative 4 times 3x is negative 12x. And negative 4 times 2 is negative 8. Combine like terms, and it's 9x squared minus 6x minus 8. And finally, 4x times x is 4x squared. 4x times negative 7 is negative 28x. Negative 1 times x is negative 1x. Negative 1 times negative 7 is positive 7. Combine like terms, and it's 4x squared minus 29x plus 7. Jeremy's noticed a pattern that he thinks is always true. If he picks any number and finds the product of one number larger and one number smaller than it, the result is always one less than the square of his number. This is a huge jumble of information. We need to figure out what it's asking. So let's say that Jeremy picks a number 5. So the number he chooses is 5. So if I pick the number, so one number larger, so the number larger than 5 is 6, and it says the product of it, and one number smaller, so 4, the result of that is 24. So it's saying that 24 is always one less than the square of his number. Well, his original number was 5, so 5 squared is 25. 25 minus 1, is that equal to 24? Yeah, it's true. That happened. So what if we pick another number? Let's say 11. So the product of one number larger than 11 is 12, and one number smaller would be 10, gives me 120. And it's saying, is that product, so if I square 11, 121, and I subtract 1, does it equal 120? Yes, it does. So now we need to give an algebraic expression that shows that it will work for any number. So if n equals any number, so we take n plus 1, because it's one number larger, times one number smaller. If I were to multiply this through, you would end up with n times n, which is n squared, n times negative 1, which is negative 1n, and 1 times n, which is positive 1n, and 1 times n. So n squared minus 1n plus 1n, and then we have, we have positive 1 times negative 1 equals negative 1. So if I combine those like terms, I end up with n squared minus 1. So is it true that when I multiply one number larger and one number smaller, that the result will be one less than the original number squared? Yes. So that is why. So which of the following expressions is equivalent to x minus 2 times x minus 4? X times x is x squared. X times negative 4 is negative 4x. Negative 2 times x is negative 2x. And negative 2 times negative 4 is positive 8. You will look that I will end up with a middle number because negative 4 and negative 2 do not cancel each other out. So it cannot be 1 or 2. If I combine those like terms, then I will end up with x squared minus 6x plus 8.